All right, so the first video we solved in finding for an imaginary number. So we were solving for I. Now we're going to talk about using I a little bit more and what type of number the imaginary numbers create. So when we have a set of, or an imaginary number and a real number together, that creates a complex number. All right, so when we write complex numbers, we write it in the sense, or we write it as A plus BI, where I is our imaginary number, or imaginary part, and A is a real number, or the real part. All right, so this is how our complex numbers are made up of both real numbers and imaginary numbers, and are written in the form A plus BI. So we can write a complex form, or complex number, in the form A plus BI, where A and B are both real numbers. So it's a real number, but it's multiplied by the imaginary. All right. If B is equal to 0, that means if B is equal to 0, we would have 0 times I, which is equal to 0. So anything times 0 is 0. So then we're left with just the letter A, which represents the real part. So if B is equal to 0, then we only have a real number, because then our B times I will cancel out to be 0. If A is equal to 0, and that means we have 0 plus B times I, and all we're left with here is BI, this is a pure imaginary number. All right, so if all we're left with is B times I, then we're left with just a pure imaginary number. So if A is equal to 0, we're only left with B times I, and that means it is a pure imaginary number. All right, just like with regular number system, or regular numbers where we can graph them, we can graph complex numbers in a complex number plane. All right, so the point AB represents a complex number A plus BI. So when we do this, our x-axis we refer to as our real axis. So that tells us how much we're moving along our real axis. So if it's 3, then we move 3 spaces to the right. If it's -3, then we move 3 spaces to the left. And our y-axis is then our imaginary axis. All right, so then if it's plus 4i, then we move 4 spaces up. If it's minus 2i, then we move 2 spaces down. So we're looking at the numbers, the real numbers, A and B. All right, it's just the I tells us which way we're moving up or down along our imaginary axis, and then the A tells us which way we're moving along our real axis. So if I give you the problem, or if I give you a complex number, 3 minus 2i, and I ask you to graph this, well, then we need to graph it on our complex number plane. So we start from the origin. So this one is written a little bit different. That is representing 1, that's representing 2, that's representing 3. So it's actually written in halves. So in this case, we will move 3 spaces to the right since it's positive 3. So we go 1, 2, 3. So then we know that our graph or our point is going to fall somewhere along this line here. All right, because our real number was 3, so we need to move along our real axis and 3 to the right. And then it tells us that our B is -2, so that means we need to move down 2 along our imaginary axis. So that's 1 and that's 2. So there's our point, 3 minus 2i. All right, now, if you're asked to find the absolute value or the distance from that origin to 3 minus 2i, or you're asked to find the absolute value of 3 minus 2i, the absolute value is equal to the square root of a squared plus b squared. So in this case, our a was equal to 3, and our b is equal to -2. So if I ask you to find the absolute value of 3 minus 2i, we would then need to do the square root of a squared plus b squared, or the square root of a, which is 3, so 3 squared, plus b squared, which is -2. 3 squared is 9. -2 squared is 4, so 9 plus 4, so the square root of 13. All right, so the absolute value of a plus bi is equal to a squared plus b squared, the square root of a squared plus b squared, or in this case, square root of 13. All right, so there's one example that we're going to go over with this, and then we're done with this video. All right, so here you're asked to find, to both graph and to find the absolute value. So if we were to graph this, remember our x-axis is our real axis, our y-axis is our imaginary axis. So in this case, it's -5. So we need to move 5 spaces to the left. So it's 1, 2, 3, 4, and then 5 will be out here. And then we need to move positive 3 because it's plus 3i for our b, so then we move 1, 2, 3. Right, so I know it's off of our grid, but that is where we would graph negative 5 plus 3i. Right, so it's pretty simple. The real number is our x-axis, so we're just moving left to right like we normally would. And then our imaginary is our y-axis, so then the number in front of the I tells us whether we're moving up or down. So that is the graph of negative 5 plus 3i. Now if we want to find the absolute value of negative 5 plus 3i, so the absolute value is equal to the square root of a squared plus b squared. So first we need to identify what is our a. Our a is equal to negative 5. What is our b? It's equal to 3. So then it's the square root of negative 5 squared plus 3 squared. Right? Negative 5 squared gives me 25. 3 squared gives me 9. And then 25 plus 9 gives me the square root of 34. All right? Then from here, depending on the question, you might be asked to round it to the nearest tenth. You might be asked to simplify a radical. So we still try to simplify a radical if possible. Or if you're asked to approximate this answer, then you would round it to the nearest tenth. But this will be your final answer, the square root of 34. That cannot be reduced or simplified. And that is the absolute value of negative 5 plus 3i. All right, that's it for this video. We still have a few more for this section before we move on to the next section.